integral of some particular functions. Let us discuss them. With this, we can wind up. We still have 10 minutes. Okay. So we know from the differentiation chapter d by dx of inverse trigonometric function. That's what we learned, right? We started our differentiation in the 12th standard by understanding differentiation of inverse trigonometric function like sine inverse of x. Can you tell me what is it? Inverse differentiation of sine inverse is root of 1 by root of 1 minus x square, right? So now what will happen if I have to have a integral of that? So integral of that is 1 by root of 1 plus x square into dx is going to be sine inverse of x. With a small additional information, instead of 1, if I have a, okay, it's 1 square minus x square. So remember that it is 1 square minus x square. If it is 1 square minus x square, if I have to, in the place of 1, if I have a square, this expression will become integral of 1 by root of a square minus x square dx, which is sine inverse of x by a plus a constant. So you can check this. Okay, all this has been proved, and some of their proofs are there in your textbook as well. Okay, so I want you to check the proofs in case if you are curious about understanding the proof part of it. Or else, please remember, if it is of the form root of 1 by root of a square minus x square, it will become sine inverse. But if it is of the form reverse direction, it is root of x square minus a square, then it will be taken as logarithm of x plus root of x square minus a square. That's one way to see it. Or cos hyperbolic inverse. So as you are not able to understand cos hyperbolic inverse, just remember this part, or directly you can remember the formula. It depends upon the option. In case if they give hyperbolic format, we have to remember this as well. Okay. So in the place of x square minus a square, if I have x square plus a square, this will become logarithm of x plus root of x square plus a square, or sine hyperbolic inverse of x by a. Okay. Yes. Now we have this special function which is of the form 1 by dx by a square minus x square. Please understand the difference between the fourth one and the first one. What is the difference? In the first three, we have the denominator within the square root, and in the last three, we have the denominator without square root. So that's a major difference. I can easily prove this part by writing this question as integral of 1 by what? A plus x into a minus x into dx. Okay. So as I don't want to stress on the proof part right now, so it's better you can check the proof of this in the textbook. So I'm trying to take this directly as the proved formula. So 1 by 2a into logarithm of a plus x divided by a minus x. Look at this formula and this formula. Here it is x square minus a square. So the everything remains as it is. In the place of this order changes from 1 by 2a logarithm of what? X minus a by x plus a plus c. Okay. Yes. So the best way to prove this is to do the inverse process of the integration, that is differentiation. When you differentiate this particular expression on the right side, you will get the original function in this format. Okay. Finally, dx by a square minus x square. It is actually plus. Please correct this. It is a square plus x square will have 1 by a times tan inverse of x by a plus c. Okay. Yes. Here there is a question where, yeah, so first they are asking, they're telling the method. Okay, so that we just saw. So let's see the question here. Here there is a question, integral of e power x divided by e power 2x plus 4. I want to integrate this first. Now I'm going to substitute, let e power x is equal to t. Now, how do I understand these things? This we can understand by only practicing it and remembering the formula. So when you start practicing in these methods, you will be remembering them easily. So now differentiate with respect to the variables on both the side. So what we get is it is e power x into dx, which is equal to dt. Now our problem becomes dt divided by t square. In the place of 4, we can write 2 square, right? So now this is of the form. Now I'll get what? 1 by 2 into tan inverse of t by 2 plus c. Now we have to replace the problem in the terms of what? What we have to, okay, we have a square root, right? So as we have a square root, this is actually, let me erase this. This is not plus, the question is different. If it is this question, it comes to tan inverse. Now, if it is minus within the square root, so what happens is, yes, so it is minus within the square root. So it will be of the form. Once I see this, what comes to my mind is, I will be thinking this question in the form of, just let me give you this. Yes, so small correction in this question. So if it is of the form, uh, yeah, this is plus, no? So what we have is integral of e power x dx divided by root of x e power 2x plus 4. So this is the form dx divided by root of a square plus x square format, which is actually sine inverse of hyperbolic inverse of uh, x by a plus c, right? So that is a format. So I need to get this form, means I need to substitute that e power x as t. If I substitute e power x as t, we get e power x into dx is equal to dt. So if this is e power x into dx, okay, so what happens is, this is of the form now, dt divided by root of t square plus 2 square. Okay, so this can be written as sine inverse hyperbolic inverse of t by 2. Is there any other formula? Can we check? Check the other formula we have here. Instead of this sine hyperbolic inverse, we can also write logarithm of x plus root of x square plus a square. That is, the depends upon the option now. So it can be written as logarithm of what? X plus root of x square plus a square plus c. Okay, if it is plus, it comes in terms of hyperbolic. If it is minus, it comes in terms of cos hyperbolic. Okay, yes. Let's see one more example, shall we? Yes. So here the example is integral of 2x plus 4 into x square plus 2x plus 5. How to integrate this? Okay, this is the problem here is, this is integral of 2x plus 4 divided by x square plus 2x plus 5. This is the question. Okay, if this is a question, first I need to write the numerator and denominator in the form of x square plus a square or x square minus a square, all right? So I'm going to take the denominator now, x square plus 2x plus 5, which can be written as x square plus 2x plus 4 plus 1. Correct? Now this is actually x plus 1 whole x plus yeah, this can be taken as 1 plus 4. Yes. So why 1 plus 4? Because then only I can see it as x plus 1 whole square plus 1. Okay. Now our problem becomes this. So we need a lot of patience and observation here. Okay. So our problem is simply now 2x plus 4 divided by x plus 1 whole square plus 2 square integral of this. Right. So now what happens here is, I need to now understand the given problem in the form of this expression. but we have 2x and what plus 4, right? So I'm going to write this now as 2x plus 4, let it be t. Okay, so sorry, x plus 1 whole square be t. So what happens then? Let's take the denominator, x square plus 2x plus 5 be t. Now what happens? It is 2x plus 2, right? But in the numerator, what we have is 2x plus 4. So I'm going to dx is equal to what? Dt, right? So we can write the given expression as now 2x plus 2 divided by x plus 1 whole square plus 2 square plus into dx plus 2 into dx divided by what? What we can write? Just tell me. We can write this as again x plus 1 whole square plus 2 square, right? So this is our denominator becomes now. So our problem now changes to dt by t, right? Yes or no? Yes. Plus integral of 2 divided by x plus 1. Again, what will happen? It will become t square plus 2 square into dt. Am I right? Yes. So now what is the problem? What happens to this problem? So in the place of dx, what we have to write? Dx is equal to what? Can you please pay attention to this? Yes. So dx will be equal to dt by 2x plus 2. So once we integrate this part, it will become logarithm of t. And this part will become what? Tan inverse of what? Tan inverse of what? X plus 2. Yes. Divided by 2 plus c. And what is our t? T is actually x square plus 2x plus 5. So this is our exact answer. So please check all the steps one by one. If it is faster, so you can come back to the recording and pause the recording and check the steps. Okay. Yes. I hope this is clear to you. So we have around 8 questions. That will be a good practice for us. I hope the question is visible. I'll be choosing only those questions which are under our concept. So the second one, that is sub question 2, is not yet been understood for us. So once we understand that concept, we can go there. Right now, I'll take the first one only. So now, how is this question given us? This question is cos x divided by sine 3x. So now we need to know what is sine 3x expansion. Without that, this will be very difficult for us. What is sine 3x? Can anyone tell me? Sine 3x is 3 sine x minus 4 sine cube x. Okay, so our problem now changes to simply our problem changes to cos x divided by 3 sine x minus 4 sine cube x dx. Now I want to make this problem very simple. So what I'm going to do is, let us assume the sine x part as let sine x be t. If sine x is t, what will happen is, if we differentiate on both sides, what is the differentiation of sine x? Cos x into dx. Do you understand why am I doing this? That's what our numerator is, right? Now our given problem becomes dt by 3t minus 4t cube. Yes or no? Now further, I need to use another substitution. For that, let me first rearrange the question as dt divided by, let me take t cube outside. So it will become 3 by t square minus 4. The 4 can be written as what? Yes, like this. T square or 4. We can keep it like this only. So now let denominator 3t square minus 4 be z, some z. Now, how do you differentiate it? So it is 3 into t power minus 2 minus 4 is equal to z. If you differentiate, it becomes minus 6, right? What happens? Minus 6 by t power minus 3 is equal to dz. Now, what is this? Minus 6 by t cube is equal to dz. It's a long process. Okay, so remember the same question I did not touch yesterday, I mean last class, because it was a part of this concept, minus 1 by 6. Now, wherever dz is there, I'm going to write it like this. Okay, dt, right? This is dt. So, do we have dt by t cube? Yes. In the place of dt by 2 cube, I need to replace it by what? Minus 1 by 6. So, the given question becomes minus 1 by 6. Okay. The denominator is now what? T. Yes. Correct? Yes or no? No, it is z now. 1 by z dz. So, the problem is minus 1 by 6 log z plus c. What is log z minus 1 by 6? Logarithm of what? Z means how much now? 3 by t square minus 4. Yes. Plus c. Okay. So minus 1 by 6 logarithm of now. T is nothing but what? Sine square. When sine goes to the denominator, it becomes cosecant square. Right. So the problem is now 3 cosecant square x minus 4. Right. Plus c. This is our problem solution. This is just a second. Yes. So what do we have here is the final part of this question is minus 4. Yes. Plus c. What is c? C is an arbitrary constant. So we need to write this. C is an arbitrary constant. Don't forget to write this. If there are someone who is strictly vigilating, they can give an excuse to remove the marks. So we always mention C is an arbitrary constant. Okay. Yes. This may be a very lengthy process, but if you understand all the steps, the logic properly, you will not miss any of the steps. Okay. That's your answer. I hope this is clear. This question is clear. Let's move on to the next one. Yes. So here there is an interesting question. The question is like this: dx divided by, I see this as 2x whole square plus 1 square. Okay, let this 2x be, let the 2x be t. The 2x is t. What happens? T into dx is equal to dt, right? So what is dx now? Dt by 2. Okay, so our question changes to now dt by t square plus 1, and integral of this is what? Tan inverse of, or dt by 2. So it will be 1 by 2 times tan inverse of t plus c. What is t now? T in terms of x, it is tan inverse of x by 2 plus c, where c is an arbitrary constant. Yes. Don't forget this, arbitrary constant. Okay, so this is our answer. Which option it is? That is option. Which one it is? Which is option? Where is it? So t is actually 2x, right? Yes, it is 2x. T is 2x, which is in the option A. They have not mentioned the constant part, so it's not a problem. If they have not mentioned in the option, we don't have to worry about it. But if it is subjective questions, you be careful, you write everything properly. Okay. Yes. Let's go to the next one. Question number 3. It's an assertion and reasoning question. Assertion and reasoning question. So what is it? First, we need to check, is the assertion correct or not? The assertion says 1 by x square plus 4x plus 2 dx. We have to differentiate this. Now what I'm going to do is I'm going to first rewrite this as x square plus 4x plus 4, correct? Am I right? Yes, plus 4. There is 2, but I written plus 4. So what I should do, I added 2, I should subtract 2 into dx. Okay. Now what we can do is, we can write this as 1 by x plus 2 whole square minus root 2 whole square into dx. This is of the form 1 by x square minus a square dx, which is actually the algorithm of what? X minus a by x plus a by x minus a plus c, right? So it is of this form. Okay, if you change the directions, it will also change. So it may go right with the reasoning, but when we solve this, we are going to replace x plus 2 by what? T. So then a will be what? Root 2. Okay, so then when you substitute this, the problem becomes dx is equal to dt. So our problem changes to what? 1 by 2a logarithm of t plus a, or we can rewrite as, if they want to maintain the right order, it is a plus t divided by a minus t plus c. And what is t here? T is actually x plus 2 and a is root 2. So our problem should be 2 root 2 logarithm of uh, root 2 plus x plus 2 divided by root 2 minus x plus 2. Correct? This is how it should be. But what we have given, they are given this. So assertion is wrong. So assertion is wrong. Okay. The only option which makes right with this option is option D. But the reason is correct because the formula which we are using is in line with the given reason. Okay. That's why the answer is option D. Assertion is wrong, whereas reason is true. Okay. Yes. So I hope this is clear. This you can do only when you know the formula well, right? Yes. Let's go to the next question. Question number 4. Another assertion reasoning question. Similar, in line with the previous question. X square plus 2x plus 3, which can be written as dx by x square plus 2x plus 1, which can be written as dx divided by, yeah, plus 2. Okay, so which can be written as x plus 1 whole square plus root 2 whole square. So these are the form dx by x square plus a square, so which is nothing but 1 by a tan inverse of x by a plus c. So here x plus 1 is nothing but I can write as t. Now the problem becomes dx is equal to dt. So integral of dt divided by t square plus root 2 whole square, which will be 1 by root 2 tan inverse of t by root 2 plus a constant c. If that is the case, what is the problem then? Final answer is 1 by root 2 tan inverse of, in the place of t, we should write x plus 1. In the place of a, it is root 2 plus c. Am I right? So assertion is true or not? Assertion is true. If the assertion is true, obviously option D is ruled out. What about the reasoning? The reason I gave is nothing but this. So assertion is true. And R is the right explanation of A, which is option A. Okay. I hope this is clear. So please check this one more time. If you have a doubt here, you can let me know. Okay. Okay. So let's go to the next question then. Which question? Question number 5, right? So we have square root. We don't have a square root here. It is simply of the form 1 by a square minus x square dx, which is 1 by 2a logarithm of a minus x by a plus x plus c. Okay. So what is a in this case? Root 30. Okay. So the answer should have been 1 by 2 root 30 logarithm of root 30 minus x by root 30 plus x due plus arbitrary constant c. Is it right? Let's check. Yes. See, 1 by root 30. This is plus x. In this case, it is plus x, and this is minus x. That's a correction. So, yes, this is the formula, and we are getting the answer similar to that. Right? Yes. Let's go for the next question. That is question number 6. So what is this? We have to prove this. It's a very interesting question. So we have to prove this, and again our basic understanding of trigonometry will help us. But once you know the proof, don't try to prove this every time. Please remember this. So let us assume x as secant theta. Why? So I'll tell you. Because there is a reason. Then theta is what? Secant inverse of x. Okay. So what is differentiation of this? Dx is equal to secant theta into tan theta. Okay. So then dx will be equal to exactly what is it? X into. So there is a small correction. X is equal to a secant theta. Okay. Then what is theta now? Secant inverse of. Let me do this again. Based on the question, we need to assume the substitution, right? So that substitution is very important. What we substitute is very important. Let us assume x is equal to a secant theta. Okay, because there is a here. That's the same way I'm taking. So dx is equal to a into secant theta into what? Tan theta. Right? This is differentiation into d theta. Okay. Am I right? Yes. Now in the denominator, there is a root of x square, which is a square secant square theta minus a square. This is why I took a secant theta. So if I take a outside, what I get is secant square theta minus 1. Am I right? Yes. So what is secant square theta minus 1? Secant square theta minus tan square theta is equal to 1. So this is actually a tan square theta. In the root of that, it is a tan theta. Okay. So what happens to our problem now? Our problem is 1 by a secant theta. Am I right? Yes. Into what do we have? This is tan theta into, in the place of dx, what we should write is a secant theta into tan theta. Am I right? Into d theta. So what we understand, this becomes simply d theta. So this is nothing but what? Theta. So what is theta here? The problem is theta plus the constant c. So but according to our question, what is theta? Theta is equal to secant inverse of x divided by a. So our problem simply becomes 1 by a times secant inverse of x by a. Okay, plus this constant theta. This is our problem. Okay, theta is by a. Yeah, so secant inverse square, secant inverse of x by a plus c. So we have proved this. So next time when you have a question like x into root of x square minus a square dx, we can directly take it as a rule. It is 1 by a secant square secant inverse of x by a plus c. Similarly, you can think about cosecant inverse as well, but cosecant inverse we avoid, we try to write in terms of secant only. And this is coming from where? This is coming from basic trigonometric identities of three identities: cos square theta plus sin square theta is equal to 1, and 1 plus tan square theta is equal to secant square theta, and 1 plus cos square theta is equal to cosecant square theta. These are the three basic identities. From there only I'm getting all this. And how can I think like this is very important. If they're asking us to prove, it's fine. But if they ask us to solve this and give the answer and it is for 5 marks, then I need to do all these steps. For that, I need to know what should I substitute for x. For that, again, these identities are important. Okay, there is always a reason behind what we are doing and why we are doing it. Okay, I hope this part is clear. Let me go to the next one. Next example solved. Next question. Question number 7. Let's see what do we have. Integral of 2 dx divided by 1 by root of 1 minus 2x whole square dx. See, it is of the form integral of 1 by root of a square minus x square dx. Can you recall what is this? This is actually, what is it? Tell me. It is the form 1 by a into sine inverse of x by a plus c. Yes or no? Correct, no? So if that is the case, what I should get? It's just a sine inverse of x by a. So in that option, you can directly eliminate all of them and you can directly go for option D. But how do you prove that? Let me show you the solution directly. Okay. See, they have taken this, they have just changed it by substitution. Yes, we can also do that, or we can do that substitution method as well. 2 dx root of 1 minus 2x whole square dx, right? Let us assume 2x as t. Okay, if you take 2x as t, what happens is d 2 times dx is equal to dt. Our problem changes to dt divided by root of 1 minus t squared, which is actually, what is it? Sine inverse of t plus c. And t is nothing but what now? T is nothing but what? 2x plus c. Yes. You can have that 1 by a, and in this case, that a is what? Yes, we need to have 1 by a, but a is equal to what? To 1. That's why it is simply sine inverse 1 by 1, sine inverse of 2x plus that c. C is an arbitrary constant, which is simply option D. Right? Yes. Let's go to the last question. Clearly, yes. Here it is an interesting question. We have this 3x plus 5 divided by x square plus 3x minus 18 dx. Okay. Now I'm going to assume the denominator x square plus 3x minus 18 as t. When you differentiate, we get 2x plus 3 is equal to dt. Okay. So now we have to write this expression in such a way that we need to get this. So what we can do is the same 3x. I'm going to write this question as a times d by dx of x square plus 3x minus 18 plus b is equal to 3x plus 5. There is a reason why we are doing it. Okay. So when you differentiate, what we get is a times 2x plus 3 plus b is equal to 3x plus 5. Now we need to understand what is a and what is b by comparing the variables. When I compare the variables, we get 2a is equal to 3 and 3a plus b is equal to 5. Okay, so a is nothing but what? A is nothing but what? 3 by 2. And what is b now? So b we have to figure out. So to find out b, I need to replace, substitute a is equal to 3 by 2 here. 3 times 3 by 2 plus b is equal to 5. So b will be now 5 minus 9 by 2, which is simply, what is it? 1 by 2. 1 by 2. So now what we can do is, we can write the entire question as, the given question as 3 by 2 times 2x plus 3 by x square plus 3x minus 18 dx plus 1 by 2 times integral of 1 by x square plus 3x minus 18 into dx. Okay, so this part is clear to you? Yes. So now I'm going to do the integration of this. Now this is equal to dt. So the first part is becoming 3 by 2 times dt by t. This is sorted out. The second part is 1. We have to again use our logic of making it as x square plus, we have to write it as 3 into 1 by 2x, right? Minus, yeah, this is a long process. This part will become 1 by 2x plus or minus, we have to go for plus 1 by 2 whole square minus 18 minus 1 by 2 whole square. So this will come as a fraction part. And we have to continue the steps. So I don't have time for explaining this part. So you can just convert this to, I'm just giving you the clue. You can convert this to x square minus or plus based on what we're getting. So based on that, we can use that formula of expansion, and this will become simply 3 by 2 times log t, and we can substitute the value there. Okay, so we have to divide this into two parts now, as this is one integration question and one integration question. And this kind of question, see the number of marks, we are getting 4 marks. So doing this properly will earn you 4 marks. Okay, so it has been a comparison question which has been given in 2019 set 1 paper 1. So it's a past paper question. So please do this. So as we are having more concept, I'm going to skip this part. So this you have to figure out later. Okay.